Hello and welcome to this webinar on the importance of existing knowledge for learning. My name is Sarah Cottinghat. You can find me on X at @scottinghat, and I have a blog on overpractice.com all about learning and teaching. I'm also a coach and work with schools on coaching as well. Today, we're going to dig down into what this means. It's quite a famous quote by David Ajibel. It often gets cited, but there's a lot to it, and there's a lot more than you'd think. So we're going to look at what this means for teaching and for our learners. You'll be familiar with this graphic. It depicts a simple model of memory. We've got components such as working memory, which is where we do all of our conscious thinking, and long-term memory, where we store knowledge. We've also got the environment. And this graphic shows us that if we pay attention to something in the environment, if we process it in our working memory, linking it to stuff in long-term memory, then we've got remembering and learning. But things we learn are also subject to forgetting. For example, if we don't use them very much, or perhaps they never make it into long-term memory at all and they're forgotten. And I've circled each of these processes because our existing knowledge, the existing knowledge of our students, affects each of these processes. It's that important. So today, we're going to look at how existing knowledge affects each of those processes. But to start with, we're going to think about how knowledge is organised. And there's a construct which, even though it's not real and you can't point to it in the brain, it's still really useful for us to think about how knowledge is organised in long-term memory. And that's this concept of schema. Schemas are networks of knowledge, connected ideas, and they kind of represent an end goal for teachers. We want students to build really rich, well-connected networks of knowledge. So we're going to start with attention, and we're going to think about how students' existing knowledge affects what they attend to. So I want to start with a piece of research. In this research, teachers who were more and less expert were shown the same videos of students in a classroom, and they were asked what they saw. Teachers that were more expert saw different things. Teachers that were less expert focused on little incidental details. You might be able to catch that one student's got fluorescent shoelaces and one of them pointed this out, whereas the more expert teachers focused on things that were more instructionally relevant, so relevant to how they might operate in the lesson to support learning and what the teacher would be doing. And this supports other findings. David Berliner, who studies teachers and teacher expertise, also found that teachers with more expertise focus on better, more meaningful aspects of the learning environment when they look at classroom environments. So what we're seeing here is that two people can look at exactly the same thing, but they pay attention to different stuff. And what that tells us is that there's something going on here. Something is causing one teacher's lens to be different from another teacher's lens. And the difference, it seems, is probably their existing knowledge. Existing knowledge guides what we pay attention to. If I know quite a bit about something, and I'm, say, sitting in a a classroom and a teacher's teaching about it, I will pick up on different things. I will focus my attention on different things to someone who doesn't really know much about it. So what this means is that your students with more existing knowledge, with better schema about a topic, are probably going to attend to the more relevant things in your explanations, or in texts that you give them to read, or in videos that they watch. It also means that those students who lack existing knowledge are going to really struggle to attend to the correct things, the most important things in your explanations, in the texts, in the videos that you show them. We need to think really carefully then about how we set our students up to attend to the most important things in our explanations. We can prime them. We can tell them to watch out for when I talk about this, watch out for the video when this happens. We can pause and draw their attention back to the right things. We should never assume that they're going to take away the things that we think they should take away. Just because we think they're relevant and that we think our students are going to attend to them doesn't mean they actually are, because attention is based on our existing knowledge. So this principle, this point, really needs to become something we think about in our teaching, not taking for granted that our students are going to attend to the things that we think that they should attend to. We need to orientate them, to prime them to attend to the right stuff. If we think back to the simple model of memory, we've talked about how existing knowledge affects attention. Well, another process on that model is learning. How does existing knowledge affect learning? When we talk about learning from a neuroscientific perspective, we talk about this idea of consolidation. And consolidation is the idea that when you learn something new, it's quite fragile to start with. It's only once it becomes consolidated that it actually enters long-term memory and is more stable. And ideally for our students, we want knowledge to be more stable so that they can access it in the long term. So there's this process of consolidation that we're going to have a look at. So when you pay attention to the environment, pay attention to something new, if your students pay attention to what you're saying, it gets processed in a part of the brain called the hippocampus. You might know this, it's the kind of seahorse-shaped part of the brain. Then with rest and sleep, we get this process of consolidation into those lovely networks of knowledge in the brain schemas. So that tends to be how consolidation happens. And remember, consolidation is taking a kind of fragile memory and making it more stable and secure, which is what we want. Now, research suggests that if students activate prior knowledge that is related to the new idea, we can actually speed up this consolidation process. So whereas consolidation takes rest and sleep normally in that top layer, actually, if we help them link to relevant existing knowledge, we can almost speed up the consolidation process. And since a lot of people think that learning actually is synonymous with consolidation, we can say that existing knowledge actually speeds up learning. You might have heard people say things like that existing knowledge is like mental Velcro. New knowledge that's related seems to stick to it. And that's true. But we can also say that it speeds up that process as well. So what does this mean for teaching? Well, we've said that activating relevant existing knowledge is important. So something that teachers can do, and teachers really should do, is to make explicit links between new ideas and students' existing knowledge. So whenever you're teaching something new, always think about explicitly activating students' existing knowledge and linking to it. Now, this has really helped when we teach using curricula that are nicely sequenced to build on one another, because we can often be relatively confident that we can activate something from a previous lesson, a previous topic that's going to help the student to understand. But sometimes linking to existing knowledge will be about linking to real world knowledge, really concrete examples that students can hang on to. This is perhaps particularly important when you're teaching abstract concepts like patriotism or democracy. And there are a variety of abstract concepts that we have to teach in all of our subjects. It's really important then to try to make the abstract more concrete and link to something concrete that students already know. So we can do this in our planning and our delivery of new material. But making existing links as a teacher by saying them ourselves is not enough. Remember, learning is only sped up if the knowledge is activated in students' minds. Now, we can't guarantee that just because we said it, that students are going to actually activate it. For many students, this might happen, but we can't guarantee it. So we also want to think about how we can, as far as possible, guarantee that they are activating that knowledge. And I call this meaningful processing. What do I mean by this? Well, firstly, it's acknowledging that meaning is not made in the words that the teacher says. It's made in the minds of our learners. So we can do tasks and set up tasks with our students that cause them to make links between their existing knowledge and what they already know. And there's a technique for doing this, which is called self-explanation, that Dunlosky talks about. So we can think about making those explicit links in our explanations and then giving students self-explanation tasks. These can be done verbally, or they can be done in written form. They could be pair work, they could be group work, whatever is suitable for that activity and for that class. But the key is that the self-explanation task causes students to make connections between what they already know and the new idea. And what this does is it sends learning down a particular path. If we help students to make those initial connections, then we send learning down a more meaningful path, that green arrow. If they don't make many connections to start with, then we send learning down a more rote-like path. And we're going to come back to this idea of paths later on. But we need to think about how we introduce new ideas. What path are we sending them down? If we make explicit links and use meaningful processing tasks, we can really help to send it down this more meaningful path with these stronger connections. So I've put a stress on the word recognisably similar ideas. The reason I've put stress on that word is because the student has to recognise the similarity. It's happening in students' minds. Just because we recognize the similarity as teachers, just because we make the explicit links, doesn't mean that they have made them. And that's why we couple this explanation that explicitly links with the meaningful processing tasks. Now on to our third process. We've already looked at attention and how existing knowledge helps us attend to the right things. We've then looked at learning and how existing knowledge can speed up student learning by speeding up consolidation. And now we're going to look at remembering. How does existing knowledge support remembering? Well, just as having a tidy cupboard with things nicely organised and labelled helps us to access the things that we need, the same could be said for knowledge as well. If we can organise knowledge in a way where it's connected, but also perhaps organised hierarchically, it's a bit more like our cupboard, where we can access the knowledge more easily. And being able to use knowledge that we have is all about access. When we forget things, it's not necessarily that they disappear, it's just that we can't access them anymore. So having the knowledge really well organised is really important. And one way that we can organise them is by concept. So we can think about the important generalised concepts in our subject and how they link to more detailed ideas. And we can think about this organisation as a hierarchy. So for example, in PE, we might have a more generalised concept of tactics, and that runs through all of the different sports that we teach. And linking to that, concepts about offence and defence, and then more detailed, ideas around goals, aggression, and pressure. And what we're trying to do is we're trying to help students to organise their knowledge in this way, so we can be quite explicit about how the knowledge is organised. And we can keep looping back to these concepts in every sport that we teach. For example, we can talk about tactics in rugby, and we can talk about tactics in football, tactics in cricket, etc. I've tried to do this today. I've taken this big concept of existing knowledge and I'm trying to link it in a more detailed way to attention, learning, remembering, and forgetting. So for me, the hierarchy exists as existing knowledge, and then these are more detailed ideas that are kind of feeding into it and sitting underneath it. So just to stress, it's the organisation of knowledge that can really help students to access it, just like that tidy cupboard. So when we're thinking about our subjects, we're thinking about what is the organisation of knowledge. And Daniel Willingham often talks about it as being kind of hidden from students. So he says that we as teachers have this idea of how knowledge is organised, but we don't always communicate that idea to students. But it's also, like we said about the schema, it's also about the connections as well. And you can see that organisation is really important, but it's those connections between ideas that are building that meaningful learning that we talked about on that meaningful path. So how can we build connections? Well, one way we can do it is we can think about variation. We can think about building multiple routes to the same knowledge. Take this example. So you can see here a chemistry example around ionic bonding. If I want to know that students really understand ionic bonding, I'm not just going to ask them to define ionic bonding in lesson 1 and lesson 3 and lesson 5, etc. I'm going to ask questions in different ways to target the same concept and really try to enrich it. So I can ask these different questions in different formats to get them to think about knowledge in different ways. For example, sodium and chlorine form what type of bond doesn't even tell the students that it's about ionic bonding. So they're having to think about lots of different types of bonding that they have learned about and think about what elements are involved and therefore which type of bonding would be correct here. So we've got this idea that to support students to remember, existing knowledge needs to be organised and connected. We can think about this at a curriculum level. We talked about this. What are your more generalised concepts and ideas, like tactics, like for me in this presentation, existing knowledge, that link to more specific ideas in a hierarchy? Then we can think on a lesson level. We've got our more generalised ideas. How are we looping back to them and then linking them to the detail in our lessons? And then we've also talked about assessment for learning, those questions, where we can vary them so that students are having to access the knowledge in different ways. And here's our key point. Organisation and connection are going to build the kind of existing knowledge that students will be able to access in the long term. So it's not just what they learn, but the way that they learn it too. Do they understand the connections that you have as a teacher in your head? Often we have curriculums that are mapped out and we understand the organisation, but how are we getting that across to students? Do they understand the way that things are organised? So our final process that we're going to look at, and we're going to look at how existing knowledge supports forgetting. Now that seems kind of like a bit of an oxymoron. Like, how isn't forgetting just forgetting? And how does existing knowledge play a role in forgetting? It seems a very strange thing to say. But actually, there are different types of forgetting, and some forgetting is better than other types of forgetting. So we're going to have a look at that now. First, we've got to remind ourselves of the different paths. Depending on the type of learning, more rote-like or more meaningful, forgetting can happen differently. And I want to explain how forgetting can happen for that more rote-like and more meaningful learning that initially happens. And hopefully you'll see that that more meaningful kind of forgetting is actually a better type of forgetting. So rote-like learning, so when we send like learning down the kind of wrong path to begin with, where students can't make very many connections, perhaps they can recite a definition or parrot back what you've said, but they don't really understand it. Forgetting tends to happen through this process of interference. What do we mean by interference? Well, interference is the idea that fragile memories get confused with other memories, get easily kind of polluted by other experiences, and are really difficult to recall in the longer term. So you can imagine some students that come into your lesson and you teach them a new concept, but they don't really understand it. When they come back to you next lesson, it's very unlikely that they're going to be able to give you a coherent sense of what you taught them. It's likely that they'll either have forgotten or they will have confused the idea and be kind of grasping at straws. This used to happen to me a lot when I was teaching. But now I understand that I need to spend more time on those meaningful connections. So that's when learning goes down that more meaningful path. So what's the type of forgetting that happens there? So we get forgetting through a loss of detail. What does this mean? This means that learning has got, that we've learnt it well in the first place, we've got those connections, and we retain the gist of the idea. We just lose some of the details of the experience of when we learnt it. And it's much better to come away with the gist of the idea your teacher taught you, because that's really much easier to recall next lesson, and then you can build upon it. So let's look at this in a bit more detail. So meaningful forgetting, that better path, that green path we just spoke about, forgetting happens through a loss of detail. So when you first learnt it, you connected it really nicely, the new idea, with your existing knowledge to produce this new meaning. And what's happened in between lessons, because you connected it quite well, is the new meaning and the prior knowledge have kind of subsumed into each other. But you're left with the gist of the new idea. Let's think of a concrete example of this. Imagine we're teaching students about gases, and they know that gases are these sparsely packed particles. Often we'll teach with like a box and the circles are kind of sparsely packed. And then I try to teach them about gases existing as molecules, like CO2. And let's say they really meaningfully connect those two ideas. I do some really explicit links and some meaningful processing tasks, and they really seem to get it by the end of the lesson. They've produced this new meaning that gases can exist as molecules. When they come back next lesson, they understand the gist that gases can be these collections of particles, but they might not be able to give me the word molecules. They might remember an example, but not all the examples I gave. They've lost some detail, but they've retained the gist. So if you think about a student that comes to you and you said, what did we learn about with gases last lesson? And they're able to tell you, these collections of particles, these particles stuck together. You can build from that. You can remind them of the details far more easily and get onto the new material in that lesson quite quickly. But if a student didn't make those connections in the first place, and they come back next lesson, you ask them what they learned and they can't remember at all, or they're getting very confused. Perhaps they're saying things like, gas is a smoke, smoke's a gas. And you're like, that's not really what we spoke about last lesson. It's going to be much harder for you to activate what you did talk about last lesson. So ideally, forgetting will happen in a more meaningful way through loss of detail, and you'll end up with that gist that you can support students to reignite next time. So hopefully this has helped to understand this quote in a bit more detail. What the learner already knows, existing knowledge, is really important for what they can learn, their attention, what they can remember, and for forgetting as well. Now we're going to take a few questions. We're going to take 3 questions about existing knowledge and what we've spoken about today. The first one is, how would you use students' prior knowledge to help them overcome working memory limitations? Now, we've touched on this, but just to emphasize some points. The first is that we always want to link to prior knowledge. And we've spoken about this idea of concrete examples. We much prefer to think of concrete examples than to think in the abstract about things. So if I'm teaching very young students about democracy, I'm going to try and link to things that they've experienced. Perhaps they're on what we call over in the UK the school council, and they have a vote for different things going on in the school. So we can link to that. We can also link to the idea of fairness and talk in a more concrete way about what's fair and unfair, because young people have a real sense of fairness, and we can make that more concrete. So by thinking about making things concrete, we can really help them to overcome those working memory limitations. What can we do as well? We can chunk things, we can break things down for our students. So if we're teaching a process to them, perhaps in maths, and they have to like solve an equation or add fractions or whatever it is, we break it down into steps. Having things in manageable chunks is much easier for working memory. In addition to breaking things down, we can also think about that in our explanations, in chunking our explanations. But we can also think about how transient the information we're giving is. If we're having to hold things in memory, that can overwhelm working memory. So we want to capture things on the board so that students don't feel like they have to hold it all in their minds. So we might use things like worked examples. We might display parts of our explanation, etc. The second question is, besides a quiz or a test, how can we activate students' prior knowledge? So really, activating prior knowledge is a difficult one to know if you've done it, because it's happening in the minds of the learner rather than the words of the teacher. So we can think about any type of questioning is potentially activating prior knowledge as long as it's targeted at that prior knowledge. We've talked about those meaningful processing tasks as really aiming to activate relevant prior knowledge so that students can link it to the new ideas. And we can think about the way that our curriculum is organised. If it's sequenced in a way that we can build on previous ideas, then that's going to really help us to activate students' prior knowledge. It's going to give teachers a real route into the new ideas. And finally, in what ways could students' existing knowledge hinder new learning? Now, we can think about students who come to our lessons with misconceptions or gaps. So if they've got gaps in what they know, then it's quite difficult to build upon that. And we can take the example that we talked about earlier with the student who's forgotten everything to do with gases being molecules, for example. And if that's the case, then it's going to be very difficult to build any new ideas on top of that. But as Mark Twain said, it's not what you know it's not what you don't know that gets you in trouble, it's what you know for sure. And actually, students can come to us with misconceptions, really deeply held misconceptions about things. So it's really good practice to work with your colleagues to kind of understand what those common misconceptions are and the best way to teach to counter those misconceptions, or to make students aware of them so that they can stop and think before answering questions, for example. And there's some nice research that's come out around misconceptions in science, which says that teachers should really support students to stop and think and access what their teachers told them about that misconception so that they can avoid making it. So thank you so much for listening to me today. I hope it's been useful, and hopefully it will help you to understand and to communicate with others why existing knowledge is so important in the learning process.